Okay, 10.2 is all about simplifying radicals, and this can be a little bit tricky for students to understand, so I definitely want to make sure we take some time and go through it correctly here. 5 boxes, so let's get into it. Number one is I'm trying to simplify 3 times the square root of 12. I've got the answer over here. I'm going to pull it out, and we're going to walk you through how we get the answer of 6 radical 3. Okay? The first thing that you can see or recognize that you want to recognize when solving these things is that if you're going to take something underneath the radical, you want to find the largest perfect square that's a factor of 12. So I could have written 12 as 12 times 1 or 6 times 2, but neither of those two things are actually a perfect square. However, 4 times 3 is a much better choice for me. The reason is because the square root of 4 is a perfect square of 2. The radical 3 can just stay as radical 3 since that's prime, and therefore I'm getting 3 times 2, which is 6, and then the radical 3 stays where it's at. That's going to be the common theme here. Whenever we're trying to simplify a radical, we're trying to find the largest perfect square, in this case, since we're dealing with a square, inside the radical to pull out. So let's try number 2 together. The square root of 160. Okay, again, I've got the answer here, and let's walk you through how we get the answer of 4 radical 10. So 160, I could have said that is 80 times 2. But that's not going to get me anywhere in terms of finding the largest perfect square fastest. The largest perfect square that's a factor of 160 is the number 16. So I'm going to break up 160 into 16 times 10. That can further be broken up into square root of 16 times the square root of 10. And since the square root of 16 is a perfect square, which I underlined twice here, that's the value of 4. Radical 10 stays as radical 10, so therefore the simplified answer is 4 radical 10. Let's try a different one, but let's do it 2 different ways, okay? Let's try the square root of 72. Let me give you the first option here, and then I'll show you the second option. The first option looks something like this. I could say 72 is equal to the square root of 36 times the square root of 2. Square root of 72 is equal to that. Okay, no problem. That's the largest perfect square, so that's going to be a 6 radical 2. So I'm in good shape. But let's just say, for example, you didn't know that 72 was equal to 36 times 2, which is, fine. Then use what you do know. You're going to end up in the same place. It's just going to take you longer to get there. Let's say you knew 72 was the same thing as 9 times 8. Okay, well, 9 is a perfect square. That's good. That's the number 3. I got you. But then you have this square root of 8. Now, the issue here is that the square root of 8 still has a perfect square inside of it right here, that 4. Okay, so you can still keep going and say this is a 3 that comes from here. The square root of 4, which we know is square root of 2. Well, the square root of 4 is just the number 2. 3 times 2 is 6. And look, you end up in the exact same place as before. So as long as you keep moving and as long as you are still trying to find the perfect squares and underneath all these radicals, you're in good shape. You're going to get to the answer faster if you can find the largest perfect square under the radical first. Let's try a different approach here. Let's try 54 n to the 7th. I'll work this one out with you, okay? So let's break this up in square. This is the square root of 54 multiplied by the square root of n to the 7th. Okay, so we got to work with 54. So the square root of 54 can be broken up into the square root of 9 and the square root of 6, because 6 times 9 is 54. Now this, I'm going to do something interesting, right? Well, I'm going to lay it out for you. I'm going to say this is the same thing as n times n times n times n times n times n, 1, 2, 3, 4, 5, 6, times another one, right? Now, if I were to combine these two, that would give me an n squared. If I combine these two, this would give me an n squared. If I were to combine these two, that would give me an n squared, and then of course, then I just have another n here, right? Well, here's the cool thing. Since I want the square root of something squared, the square root and the square would cancel out, and an n would be able to come out of the radical. So here's what I'm going to have. This is the number 3. We know that, right? 3 times 3 is 9. I'm going to have a square root of 6. I'm going to have an n from this square root. I'm going to have another n here from this square. I'm going to have another n from this square, and then I'm finally going to have the square root of n because I cannot do anything. I can't release this one underneath the radical. So look what I have. I have 3n to the 3rd multiplied by the square root of 6n, and this is the simplified radical form. So I think the key here is rewriting the index, which is a 2, to match the factors of my 7. So I could just rewrite this as n squared times n squared times n squared times n to the first. And every time I have a square root of n squared, square root of n squared, each of those just becomes an n. And that's why I have an n cubed down here. That's a tough one. Okay, here we go. Let's try to work with this one here. Let's do 2 times the square root of 7t times 3 times the square root of 14t squared. Well, the first thing that we can do is we can multiply the 2 and the 3 together, and we can get a 6 out of there. That's no big deal. And then if I multiply under the radical, I'm going to end up with 98t to the third. 7 times 14 is 98. T times t squared is t to the third. All right, let's pick it up from here and show you how to take this apart. All right. So I've got the 68, or 6 times the square root of 98, and then I have a t to the third. I've broken this up. 98, the largest perfect square underneath 98 should be 49 and 2. That's easy to see because 49 is the number 7. 7 times 6 gives me back that 42. My rad 2 stays there. My square root of t to the third becomes square root of t squared times the square root of t. Now I do the same trick, right? If I have the square root of t squared, I can have a t pop out. I cannot release this t because the index is larger than the exponent. Thus, the final answer when I'm done is 42t times the square root of 2t. Again, a challenging problem, and these are going to take a little bit of work, but you'll get it eventually, okay? Okay, last little box here. Let's talk about this one, and then I'll show you how to do the last one altogether. About the square root of 64 over 49, okay, I am allowed to break up a square root over division. That's just the square root of 64 divided by the square root of 49. Well, the square root of 64 we know is 8, and the square root of 49 we know is 7, so therefore the answer is just an 8/7. That one's pretty easy. Let's do this next one. Square root of 8x to the third over 50x. Well, here's how you get the answer. I can simplify 8x or 8 and 50 into 4 and 25. I can also simplify an x to the third divided by x by a single x squared on top. Now I can break up the radical over division, say square root of 4x squared and square root of 25. Well, this just becomes a 2x, and this just becomes a 5, right? The square root of 4 is 2. Square root of x squared, there it is again, of course becomes an x. Now sometimes you're going to see a problem that looks like C here where you can't really do anything. And the thing that you're going to want to do is only rationalize the denominator. So what I mean by that is I can multiply top and bottom by the square root of 7 over the square root of 7 because after all, this is just a fancy 1, right? So I'm allowed to do that without breaking any rules or anything like that. So doing so then was going to give me the square root of 21 over 7 times 7 is, or square root of 7 times 7 is just the square root of 21 over 7. And that's it. So lots to review, lots to work on, but let's get these homework questions in and we can proceed from there.